Let me talk about assignment 3. So assignment 3 was very simple. So basically, what you had to do is, so I gave you a screenshot, the sample screenshot of the business application, and based on that, your job was providing a document structure, which is able to manage data, which is shown on the screenshot. But when we click a certain page of the user, we want to show 50 connections on that page as soon as possible, as fast as possible. So that was the main objective of the assignment 3. So basically for the assignment 3, here is the sample solution. So the best way to achieve that is simply creating two collections. The first collection you have to create is the user collection. So in the user collection, basically you store information about the user. So basically something like user ID, name, description, location, and the total number of connections. So you may store a user-specific information so that you can make these fields inside the user document. And then the number of pages you may create or not, it doesn't matter. And connections here. So, and then you can use the embedding approach in the user document. So you may create a connection field inside every user document. And inside the connection field, you may store a list of embedded documents. So basically, a list of 50 first 50 connections of the user can be stored inside here as a list of sub-documents. And each sub-document will contain a simple information about that connected user. So something like the user ID, this 10001, this person is connected to user ID 12345, and this person's name is Daniel, description is a final year student, and image is something like this. So you may create something like this. So that will be the user collection basically. And then you may create the page collection. So page collection is basically inside the page collection, every page document is there for 50 connections on a certain page of a certain user. So here we can use embedding approach again, kind of a hybrid embedding approach in this case actually. So every page document will contain user ID to represent a certain user and page field to represent a certain page of that user. And then it will also contain this connection field, which will have a list of 50 connections on a certain page of a certain user like this. So in this way, if we simply retrieve this page document of a certain user on a certain page, we'll have this 50 connections information stored inside this connections list. So that will be the, basically that will be the main design you may create for the page collection in this assignment 3. So that's all. So basically, this is the sample solution which is able to achieve fast read operation when a user clicks a certain page of a certain user. So in the next page, so here I briefly explained the common mistakes which were made by previous students when I taught this course. And also I provided some comparison, the speed comparison between sample solution I provided here and the common mistake you may make. So the best way to understand how fast your document structure will be is simply making some assumption and you can calculate it. So you can assume that you may have 1,000 users and each user may have 500 connections. So based on that assumption, you can calculate how many documents should be scanned by MongoDB when you perform read operation. Then you will be able to know how fast your design will be able to provide that kind of operation. So let me talk about some common mistakes people are usually making here. So one of the common mistakes is this. Instead of having page collection, you may have a connection collection. So if you remember when I was talking about the document design in MongoDB in the class, in the slide there is this example of hybrid design. So in hybrid design, basically what I did is that in the main document, in the user document, I used the embedding, and for the rest of the tweets, I used the referencing approach. So if you do the same thing, then you will have a connection collection instead of a page collection. And inside the connection collection, you will simply represent the connection of a certain user from after the page one. So in the user collection, in the user document, you have first 50 connection, but from 50 first connection, you may simply have that information on the connection collection as a referencing approach like this. In that case, for each document inside the connection collection, we'll have a user ID, connected user ID, and some of the information of that connection like this. In this case, you are using referencing approach basically. However, if you do that, it will be slower than what I showed in the sample solution. It's because of this. If you assume that we have 1,000 users, and each user has a 500 connection, then based on the assumption, we can calculate how many documents we need to scan to show 50 connection on a certain page of a specific user. So if you calculate that information, based on my sample solution, basically, if everyone has a 500 connection, it means everyone has 10 pages, basically, because each page document contains 50 connections. So that means if we have 1,000 users and if everyone has 10 pages, then the page collection will have 10,000 documents, basically. So if we want to retrieve a certain page of a certain user, if we scan all the documents inside the page collection, in total, we will have to scan 10,000 documents. So that's basically the number of documents we need to scan for a sample solution. However, if you use this approach shown in the common mistake 1, then we don't have a page document. Instead, every connection is simply listed inside the connection collection. So we have to scan 500 documents for every user. So we have a 1,000 user. So 1,000 multiplied by 500 will be 500,000 documents to scan to find 50 connections of a certain page of a certain user. So basically, it will be much slower compared to the sample solution in this case. So that's one thing. And another common mistake is here. The common mistake 2 is this. For page collection, you made a page collection and you also made a page document which represents 50 connections of a certain page of a certain user. So you did that. So actually, you actually have a user ID and page number, and also you have a list of connected users stored here. However, instead of storing embedded document, you may simply store the ID of connected users. So that's also possible. But if you design like this, the problem is this. In a certain page of a certain user, let's say that page 2 of this user 1, 2, 3, 4, 5, we have to list 50 connections. So 50 connection information is here. So we know the connected user's ID. However, for each user, we don't know their name. We don't know their simple bio. So those information is not here. So what we have to do is that using this ID, we have to look for user documents of that person again to retrieve those simple information. So basically, in this case, if you design like this, we need extra time to scan user document here, basically. So this approach will be about 10% slower than what I showed in the sample solution. The last one, the common mistake 3 is this. So you did everything correctly as what I showed in the sample solution, but you may add one more field, something like pages. So you may create a pages field, and here you store a list of pages for a certain user, for that user. So sometimes I see that some students make this field like this. However, this is actually not a good design because the page number, we can actually infer that from number of connections. So if someone has 1,590 connections, if we simply divide this number by 50, then we know how many pages this person has. But the problem is the problem of making pages field like this is this. So if we have a pages field, basically the thing is that we don't know what is the upper limit of the page number. So if someone is a celebrity or someone is a really popular influencer, that person may have a lot of connection, and the connection may increase further. In that case, in the future, maybe this person has a 10 page, but it will keep increase. Maybe in the future, this person may have 100 page, 1,000 page, something like that. And this number, this list will keep growing. And the problem is that because there is no upper limit of the page, there is no upper limit of how many connections you may have, the size of this document will become really big if this list keeps growing. Then the MongoDB has this document size limit over 16 megabytes that may exceed. That's one problem. And also another problem is that if you have like a really big document, it will be slower to retrieve this document from the coding. So that's another problem. So basically, having a list of pages stored inside the user document or page document is not a good approach. So that's why I put this as a column simplicity here. Okay, so that is basically a sample solution here. So one thing I have to mention is this. So this document structure here on the sample solution is designed to optimize to provide fast read operation. So if you have this document structure, then when a user clicks a certain page, then 50 connections can be retrieved really fast. So it provides a fast read operation. However, if you try to insert or delete a connection, it will be slow actually. So let me tell you why. The reason is very simple. Because we have connections stored like this using embedding approach. And also here, right? So let's just say that for user 1, 2, 3, 4, 5, let's say the user 1, 2, 3, 4, 5, he is not friendly with Tom anymore, something like that. And the user want to delete this connection. So now Tom and user 1, 2, 3, 4, 5 is not connected anymore. If that happens, we have to delete this connection basically. We have to delete this element from the list. Then this connections field will have only 49 connections inside. So it's not 50. So what we have to do is that after we delete this, we have to go to page 3 and we have to bring this into page 2. And we have to do the same thing for other page. So on the page 3 document, we have to go to page 4 and bring one element into here. And we have to go to page 5 and we have to do the same thing. So simply to delete one connection, this, so simply to delete one element, this, we have to update so many documents. So the delete operation and insert operation will be slow if we use this design. However, it is totally okay. Why it's okay? Because it's an online service, and most of the online service, most of the operations that happen in the application is a read operation. So you go to social media, you go to LinkedIn, and you will try to look at information from other users or from friends. So you read a lot of information. You send a lot of read requests to the system. However, it is very rare to add a new connection or delete a new delete an existing connection. So just think about it. If you use the Facebook or any other social network today, you probably went there to read information. However, how many times do you delete your friend, or how many times do you add your friend? It doesn't happen that much, right? Probably for a few months, it may not happen at all, and it may happen only like a few times in a year or something like that. So that's why it's okay. So that's why in this design, it's better to focus on providing fast read operation in this case. So that's why yeah, this sample solution is designed in this way to optimize to provide a fast read operation.